17th of August 2022. So folks, what you've just seen there is, here is the gear train. And that connects the mandrel, the spindle going around, which has a hole in it there to allow you to put stock in there. That connects it through this wheel here, which has either 30, 32 or 40 teeth per wheel on it, through an intermediary, and back to one here with 40. You can select whichever you want, depending on the scale or whatever thread you want. And then there are two levers here which provide you with gearing for the various threads. This one here switches between the lead screw and the feed screw, and this one here is for forward and reverse. So they're a very, very versatile machine. Now I just want to show you here, this is the lead screw. This is the one for cutting threads, and this one here is the feed screw. And they're two different screws, and you select them based on this lever. Now we'll just give it a run. Now a switch. Now I hope you can see there that the two are operable. One, the feed screw is to feed the work on here, and the lead screw is to cut threads. On some lathes, some smaller lathes, the one shaft does both. The one shaft does both. Now, for cutting the like of this here, that surface, you use the feed screw, and that will allow you to cut this way or that way. And on cheaper lathes, that's often done by hand. But one thing which cannot be done by hand is to cut threads. And to cut threads, you use a V cutter, which runs along and cuts this at a given rate. Now, most lathes have a 4 for big lathes, or an 8 teeth per inch lead screw. The feed screw is different. It just drives the cutter, and it drives it through a set of gears, and it's not precise, but the lead screw is very precise. So if you're cutting 8 teeth per inch, you'd connect the lead screw to revolve at the same speed as the headstock, as the work. If you want to cut 16 teeth per inch, you have the headstock or the work revolving at twice the speed of the lead screw, and so on. So it's easy enough getting any thread that's a multiple or a divisor of 8, because the lead screw has 8 teeth in it. Now there are gears here that allow you to cut odd sets of gears. You can cut different ones on them. I don't know, can you see them there? And most will allow you to do that because they have a gearing inside here that's worked with these two screws. But where the problem arises is where you want to cut metric. Now, I'm going to stop just here for a second. Now, the metric system is based on a cubic meter of water weighing a ton and containing 1,000 litres. And the meter is based on the length, the distance light travels in a vacuum. And the speed of light is the fastest that there can be in this universe. So the thing about it is, the speed of light is the basis for the metric system, okay? And there's a rod kept in Paris, and it's kept at 20 degrees, and that's the final decider of the length of a meter, okay? Now, when the meter was being settled, the imperial system had no comparable measurement. There was no exact length. There may have been slight variations between Australia, Britain and Ireland, Canada, America, and all that. So there wasn't an actual ruler to be a yard long or a foot long. And so what they just looked at was the inch. And the inch at that time was as close as makes no difference to 25.4 millimeters per inch. 25.4. Now, they were able then to say, right, why don't we make an inch equal to 25.4 meters and have that as standard? And because of that, the imperial system is actually based on the metric system. Okay, they said forevermore an inch has 25.4 millimeters, and as 25.4 is not too awkward, it's not too big of a fraction, not too big of a decimal place, it's very handy. Okay, so now you see that if you had a wheel with 120 teeth, sorry, I just put this in here. If you had a wheel with 120 teeth, that'll divide by 8, giving you 15. And if you had a tooth 127, that'll divide by 25.4 to give you 5. So 25.4 is 127. Now, so you have a wheel 32, you're driving a wheel with 120 and 127, and it's driving a wheel with 40. And we'll just stop there now. So here we have 32, which is divided by 8. 8 will go into it 4 times. You have it driving an intermediary wheel, which is 120 and 127 teeth. And that drives a wheel with 40 teeth. So all this one and this one are divisible by 8. They can be divided by 8. And this one here, divided by 8, will give you 15. And this one here, divided by 25.4, gives you 5. And then by arranging the gear train here and the gears here, you get an exact millimeter metric tread. It converts the lead screw from imperial 8 teeth per inch to nearly all metric treads, like 2 millimeter, 1 millimeter, 1.25, and all of that. So you probably won't read this, but you see the inch and the millimeter, and then it gives you what wheels to use. You see that? See the wheels there, and how to arrange your intermediary, and which one to use. How to use the levers. There are 2 levers. See there, and you can see the various metric treads you can get. And I have cut all the handy ones on it. So now we'll move here. I don't know can you read this, but this lathe is a Shenhua 900 and it was made in Taiwan. These lathes were marketed as a cheap alternative to the standard lathe. It's a 3 foot by 12 swing lathe. Yeah, they were a wee bit cheap, but they were great bed and very good. It's always done my purpose. I got great enjoyment out of making things with it. So this is a little Stewart S50 steam engine model. I bought the casting a long time ago and then made it. And I had a boiler, and the water in the boiler wasn't kept minded, and it rusted the boiler or damaged it. But this is the wee steam engine. Example, sorry, of things you can make. So, see that there? It's a bit stiff. So still tight. That's it there. Turn around. So this is it here. Little mill engine. You buy the castings and then you bore out the cylinder and you turn the flywheel and all of that sort of stuff. It's a bit dusty and it has been put away in a cupboard. So it's an idea of the things that, some of the better things that I've made on it, but made a lot of stuff on it as well. This is a calipers here, designed for measuring. I've taken the splashback off this because I need to get in behind it for certain work, and therefore it skates the window, not a big deal. But goose grease, funny enough, Goose grease is one of the best lubricants you can find. It's actually one of the best lubricants I know of for lubricating, cutting and all that. So basically, folks, what I've showed you here is the ingenious way that the maker came up with converting the 8 TPI, 8 teeth per inch lead screw, imperial lead screw, to the metric system, using the fact that the inch converts to 25.4. My battery's getting low, folks. We leave it at that, and we'll see you back. Give me a thumbs up and a thumbs down. Thank you.